In today's video, we are going to cover the ratio and root tests as well as power series, and our ratio test formula is the L equals the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. Our root test formula is L equals the limit as n approaches infinity of the nth root of the absolute value of a sub n, where I like to put it as the absolute value of a sub n to the power of 1 over n, because I think it's easier to plug in for me personally. And the reason why we use these tests is because these formulas calculate the limit of a given infinite series. So if your conclusion is L is less than 1, your series will absolutely converge. If L is greater than 1 or L equals infinity, the series will diverge. And if L equals 1, you would want to use a different test. Now, overall, these tests will lead up to power series, where the formula is the summation of a sub n, x minus c to the n. And this power series will help us find the radius of convergence, which is written as r, as well as the interval of convergence, which is written as I. And we will be going over all of this with our problems today. So let's let our first problem be the infinite series from 1 to infinity of 2 to the n over n factorial. Now, when you see that there's an nth power as well as a n factorial, a good way to remember a ratio test is by those two factors alone. So this leads to ratio test. Now, remember that our ratio test is stating that our limit from n to infinity is a sub n plus 1 over a sub n, all inside an absolute value. And let's try to find these factors. So a sub n plus 1 is basically just replacing every single n with n plus 1. So this would be 2 to the power of n plus 1 over n plus 1 factorial. So that is your a sub n plus 1. Now down here, our a sub n would be just 2 to the n over n factorial. Now all you have to do is just plug in these values into the formula, which what I like to do is just leave the a sub n plus 1 exactly the same as it is, but multiply by the reciprocal of the a sub n. Since basically dividing it is multiplying the denominator over here to the top part over here. So I just like to think of it as taking the reciprocal and multiplying that instead. So flipping it upside down, it'd just be n factorial over 2 to the n under the absolute value sign. Now we can further simplify this by just simplifying it. So our limit as n approaches infinity is 2 to the n times 2, because of this 2 to the n plus 1, which is just the same as 2 to the n times 2 to whatever this number is, which is to the first, which is 2, and then over n plus 1, but this time we're going to subtract the 1 by 1 and get n and end it with a factorial. Now if you're wondering why I did that, our goal is to cancel out as many terms as possible, and if we can cancel out this n factorial. So our other side will look like n factorial over 2 to the n under an absolute value. Now, because of the way we simplified it, we can cancel out this 2 to the n with this 2 to the n, and this n factorial with this n factorial. So our result is the limit as n approaches infinity of the absolute value of 2 over n plus 1. Now, plugging an infinity sign into our n just gives us a 0. So our L equals 0. And remember, over here in our rules, if L is less than 1, then it will converge absolutely. And because 0 is less than 1, our infinite series from n equals 1 to infinity of 2 to the power of n over n factorial converges absolutely by ratio test. Now let's move on to the next one. All right, so let's let our second problem be the infinite series from 1 to infinity of 5n minus 3 over 3n plus 2 to the power of n. Now because our a sub n over here is raised to the nth power, we know that we will use the root test, which again states that the absolute value of a sub n under a square root to the nth power is the form we will use. And of course, taking the limit of that is the proper way to say it. But how I like to do it is just think of the absolute value of a sub n to the power of 1 over n. It's the same exact thing, but to me, plugging it in a calculator is just a lot more straightforward to me. So that's how we're going to do it. Now, of course, our a sub n here is the 5n minus 3 over the 3n plus 2. And we'll take the absolute value of that. And of course, the limit. And sorry, I forgot to put parentheses to the nth power. And then all of this to the power of 1 over n. Now what makes this fairly simple is that our n and our 1 over n cancel each other out. So all we're left with is the limit as n approaches infinity of 5n minus 3 over 3n plus 2. Now from here, I just like to take the highest power over the other highest power, which in this case luckily are the same, which is to the 1. So this is just going to be 5 over 3, which is equal to our L. Now remember, on our rules over here, if L is greater than 1, or L is just bigger than 1 in general, this will diverge. So the series from n equals 1 to infinity of 5n minus 3 over 3n plus 2 to the power of n diverges by the root test. And then let's go on to our final problem. So let's let our next problem be to find the radius and interval of convergence for the series from 1 to infinity of x minus 4 to the power of n over n. Now, if you notice, our ace of n is not to the power of n, so we didn't use root test in this case. We would use ratio test, which again, the limit to infinity of the absolute value of ace of n plus 1 over ace of n is our ratio test form. So our ace of n plus 1 is x minus 4 to the power of n plus 1 over n plus 1. And then our ace of n equals x minus 4 to the power of n over n. And again, I just take the reciprocal of this ace of n and multiply it by our ace of n plus 1. So our limit as n approaches infinity of x minus 4 to the power of n plus 1 over n plus 1 times n over x minus 4 to the power of n, all under an absolute value. Now we can simplify this by just saying that the limit as n approaches infinity of x minus 4 to the power of n times x minus 4 over n plus 1 times n over x minus 4 to the power of n, all under an absolute value, and then cancel out this x minus 4 to the power of n with this other x minus 4 to the power of n, which will get us L equals the limit as n approaches infinity of the absolute value of x minus 4 times n over n plus 1. So now we could take out this x minus 4 since it doesn't apply in the limit, since there is no n. So the absolute value of x minus 4 times the limit as n approaches infinity of n over n plus 1. Now if we just take the higher orders of both, or use L'Hopital's rule, we will just get 1. And so it would be x minus 4 under an absolute value times 1, which of course gets us x minus 4 under an absolute value. Now to find the radius of convergence, we know that the series will converge if the L is less than 1. And remember, our L in this case is this x minus 4 under an absolute value. So we could just say the absolute value of x minus 4 is less than 1. So if we set this in an inequality, we know our radius is 1. So it will go from negative 1, because we're doing 0 minus 1 and 0 plus 1, which is less than the absolute value of x minus 4, which is less than 1. Now, all we have to do is just add 4 to both sides, which will then get us 3 is less than x, which is less than 5. And again, how I got my radius of convergence was simply from the form absolute value of x minus c is less than r, where r is our radius, and in this case, our radius was 1. Now, we do have our radius, which is 1, but what is our I? Well, to find that out, all we do is just plug and test our endpoints, which is 3 and 5, into our series, which was the infinite series from n equals 1 to infinity of x minus 4 to the power of n over n. So we just plug in 3 into our x, which gets us 3 minus 4 to the n over n, which is simply just negative 1 to the n over n, which by alternating series tests, since we do see that negative 1 to the power of n, we can see if it converges or diverges. So again, our test for alternating series test is if it's positive, decreasing, and the limit becomes 0. So in this case, if we did take the absolute value of negative 1 to the n, we would just get 1 over n, which is our b of n in this case. And because our b of n is greater than 0, since all our terms will be positive, this will be positive. So it passes that. Now decreasing is just comparing our ace of n plus 1 to make sure that it's less than our ace of n, which in this case, if we plugged in 1 over n plus 1, we would know that plugging in 1, 2, 3, 4, 5, our 1 over n will always be bigger. So it is always decreasing. And lastly, our limit is 0, meaning that as n approaches infinity, 1 over n should be 0, which is true. So that passes that too. So by alternating series tests, which I'll just set as AST, this series converges when x equals 3. So again, back to our interval, since it converges, right, that means that we know our 3 is going to be a bracket. So our interval will be a closed bracket on 3. So now the next step is to test out our 5. So doing the same exact process where our infinite series of n equals 1 becomes 5 minus 4 to the power of n over n, since we plugged in 5 for x, which then gets us 1 to the power of n over n, which is the same exact thing as 1 over n. And if this form looks familiar, that's because this is a p-series, where our p equals 1. And so this one wasn't too hard. We just determined that this is a p-series and p equals 1. And remember, if p is less than or equal to 1, then our series diverges. So by p-series, which I'm not sure if you have to say that, but by p-series or harmonic series, this series diverges at x equals 5. So in conclusion, after all of this information, our interval of convergence will include 3, hence the rectangular bracket, but will not include 5. So this is going to be rounded. So it's going to be a parentheses. So bracket means included, and then this parentheses means not included. So in conclusion, our radius of convergence equals 1, and our interval is including 3 but excluding 5. And we are done.